When you think about artificial intelligence, well, most people probably jump straight to things like ChatGPT, right? Or maybe self-driving cars.
Yeah, that's the common picture now. Definitely the most visible stuff.
But here's what's really fascinating, I think. The actual quest for AI, it goes back way further than any computer.
Oh, absolutely. Today we're doing a deep dive into that surprisingly long history. It's really captivating stuff.
So what's the mission here?
Well, we want to trace AI's roots from, ancient philosophical ideas and these amazing old mechanical devices,
Yeah.
right up to the powerful models we see today.
And look for patterns, maybe.
Exactly. Patterns of innovation, the waves of optimism, the inevitable challenges. It's quite a cycle.
And I guess what you find is it's not just a straight line forward, is it?
Not at all. It's much more tangled.
Huh.
Ideas converging, these periods of huge excitement followed by, well, winters, they call them. And the definition of intelligence itself keeps shifting.
Okay, so where do we start? The ancient seeds.
Right. You can really see two main threads starting way back, but interestingly, running parallel for a long, long time.
Two threads, what were they?
So, on one side, you've got philosophy. Think ancient Greece, Aristotle trying to pin down logic with syllogisms.
Little rules for thinking, basically.
Exactly. And later, people like Descartes asking, how does the mind relate to the body?
Yeah.
Where does thought come from? It's all groundwork for kind of mechanizing thought.
The software, you could say, but without the machine.
That's a great way to put it. And then completely separately, you had this desire to build self-moving machines, automata.
Ah, like Hero of Alexandria. And didn't Al-Jazari build incredible automated figures too?
Yes, amazing stuff. And later, Vaucanson's digesting duck in the 18th century. Just incredible engineering for the time.
But the philosophy and the engineering, they weren't connected yet.
Not really. The software guys didn't have the hardware, and the hardware guys weren't really trying to replicate formal thought. That connection was missing for centuries.
So when did that start to change? What bridged that gap?
The big leap really came in the 20th century, with the idea of formalizing computation itself.
Okay.
Alan Turing's work in 1936 was fundamental. His abstract Turing machine gave us a universal definition of an algorithm.
And the implication was, if thinking is just computation.
Then a machine could potentially do it. Then you had McCulloch and Pitts in 43 modeling a neuron as a simple computing element, suggesting the brain itself is a kind of computer.
Wow. So the pieces are starting to come together.
They really are.
Yeah.
And then the field gets its name and, well, its big, bold mission statement.
You mean the Turing test?
That was part of it in 1950. Turing shifted the question. Forget, can machines think? Let's ask, can a machine's conversation be indistinguishable from a human's? A practical test.
And then Dartmouth in 56.
Exactly. John McCarthy coins the term artificial intelligence. And the workshop famously declared that basically any aspect of intelligence could, in principle, be simulated by a machine.
That's incredibly optimistic.
Hugely. And it kicked off what they call the golden years, roughly 56 to 74. Lots of government funding, loads of optimism. Symbolic AI was the focus.
What kind of things did they build?
Programs like Logic Theorist, which could prove mathematical theorems, ELIZA, which could simulate a conversation, sort of, and Shaky the Robot, trying to integrate perception and action. Impressive, but often in very controlled, simple micro-worlds.
Okay, micro-worlds. That sounds like a limitation.
It absolutely was. And that led straight into the first AI winter, around 74 to 80.
Reality bites. What went wrong?
Well, those early methods just hit a wall. They couldn't handle complexity. The combinatorial explosion, too many possibilities to compute for real-world problems. The big promises weren't met.
And funding dried up.
Drastically. Big critical reports like the Lighthill report in the UK basically said, this isn't working as promised, and the money disappeared. A really tough lesson.
But AI didn't die out completely. What happened in the 80s?
A comeback, but more pragmatic. The rise of expert systems. The idea was, forget general intelligence for now. Let's capture narrow human expert knowledge in specific domains.
Like that DEC system, XCON.
Exactly. XCON configured computer systems. It saved DEC millions. It showed AI could have real commercial value, but in a limited way.
But that didn't last either. Another winter.
Kind of a late 80s, early 90s. Those expert systems were brittle. They broke easily if you went outside their narrow expertise.
Right.
And getting the knowledge in was a huge bottleneck. Very expensive to build and maintain. Plus, the market for specialized AI hardware, like Lisp machines, collapsed.
So boom and bust cycles seem to be a theme here.
Definitely. But out of that second winter, something different started growing quietly at first.
What was that?
The statistical turn. Through the 90s and 2000s, the focus shifted away from hand-coded rules towards learning patterns directly from data.
Ah, machine learning taking center stage.
Precisely. Better algorithms started appearing, things like support vector machines, LSTMs for neural networks, and crucially, more data and more computing power were becoming available. It was less about explicit programming, more about statistical inference.
And that set the stage for the explosion we've seen recently.
Absolutely. The deep learning revolution from the 2010s onwards. It was a convergence.
What converged?
Massive data sets, like ImageNet for images. Powerful GPUs, originally for graphics, turned out to be perfect for training neural nets. And refined deep neural network architectures.
And we saw breakthroughs like AlexNet winning image recognition contests.
Right, in 2012. A huge moment. And then AlphaGo beating the World Go champion in 2016. These systems showed capabilities nobody thought possible just years earlier.
Driven by scale.
That became the key idea. More data, more computing power, bigger models. It seemed to lead to qualitatively better, sometimes surprising emergent abilities.
Which brings us pretty much up to date with foundation models.
Yeah, the current era. The transformer architecture, introduced in 2017, was pivotal. It allowed for building truly massive models trained on internet-scale data.
Like the GPT models behind ChatGPT.
Exactly. Using generative pre-training, they learned this incredibly broad knowledge base and startling abilities like in-context learning just from processing vast amounts of text.
They're transforming fields, no doubt, but they have issues too, right?
Oh, definitely. They can hallucinate, make things up confidently. They inherit biases from the data they're trained on, and the sheer cost and resources needed to build them raises big questions about access and who controls this power.
So looking back at this whole sweep of history, it's quite a story, a synthesis of logic, mechanics, statistics.
And these recurring cycles, right?
Yeah.
Hype, disillusionment, then a paradigm shift, and the cycle begins again, often with a redefined goal for what intelligence even means in this context.
It really makes you think.
It does.
So maybe the thought to leave you, the listener, with is this. Knowing this cyclical history, this constant redefinition of AI's potential and limits, how does that shape your view of intelligence itself? And how should we think about navigating the future implications wisely?